In section 9.2, we're conducting a hypothesis test looking at the difference between two means, and in this case we're looking at independent samples. So what this means is we're comparing two independent groups, and we want to determine if these two groups have a different mean, if the mean between the two groups is different. And it'll follow a similar structure to the way that we performed the hypothesis test in comparing two proportions. So the requirements are that we're looking at samples that are independent and random. The values of the standard deviation are sigma 1 and sigma 2, and they're unknown. And either the populations come from a normally distributed population, or each of the sample sizes are greater than 30. And in this case, our null hypothesis will be that the mean between our two groups is equal to each other. And the alternative hypothesis is that they're different in some way. Either they're not equal, mu1 is less than mu2, or mu1 is greater than mu2. As usual, our level of significance, alpha, will be by default 0.05 as the probability of making a type 1 error. And here we have a different test statistic, but it follows the same structure. And generally what we're using is x1 bar minus x2 bar is the difference between our two sample means. Mu1 minus mu2 would be the difference between our assumed population means between the two samples. And in this case, because we're assuming that mu1 is equal to mu2 in the null hypothesis, this is usually just going to equal to 0. And based on the type of alternative hypothesis we're using, either we're going to have a left tail, a two tail, or a right tail. And then the decision we make will follow the usual choice that we're making. If its p-value is less than or equal to alpha, we reject the null hypothesis. If the p-value is greater than alpha, we fail to reject. And then we'll determine our conclusion, which is usually going to be following from whatever mu's, or whatever mu1 and mu2 represent. We'll determine whether or not they're equal and whether or not we have evidence to support the alternative claim. Okay, so in this case, our calculator function that we'll use when we're looking at examples here will be the two-samp t-test. Okay. What it'll ask for is it'll ask for a mean from each of the groups. It'll ask for a standard deviation from each of the samples, and a sample size from each of the samples. And then, of course, the form of our alternative hypothesis will be one of the forms mu1 is less than mu2, mu1 is greater than mu2, or mu1 is not equal to mu2. So it's one of those three forms. And in this case, we'll be looking at the ones that are not pooled.